All right, so we're going to keep going on this sheet. We started yesterday. So we are not going to do the section that's reference angles. I feel like I told you that yesterday, but I'm not sure. There's nothing wrong with doing reference angles. I just think for what we're going to do, it's just not that important. But we are going to do this bottom section that has where it says trig functions. And so we are going to let theta be an angle in standard position where there's a point called the xy, and that point is on the terminal side of theta. So this is what we're talking about over on this side. So this is our angle here. And then here's our point that's on that angle. And the distance from the point to the origin is r. And if we want to find r, we're going to do x squared plus y squared equals r squared. Now, that is the Pythagorean theorem. Just instead of with a, b, and c, it has x, y, and r. So when we are doing the stuff today, we're not necessarily going to do SOHCAHTOA, even though it ends up being the same exact thing. We're going to use a different set of rules that use the x, the y, and the r. So if we have a point and we want to find the sine of the angle formed from that point, all we're going to do is take the y and put it over the r. All right. For the cosine of theta, we're going to take the x and put it over the r. And then for the tangent of theta, we're going to put the y over the x. Now, it is a new set of rules to remember, which is kind of frustrating, but I feel like using the x, y, and r rules is a little bit easier than doing the SOHCAHTOA rules. All right, and then the reciprocal, we'll just flip them over. All right, so we're going to do this example 17, and then I made a few more examples for us to do because I just didn't feel like one was enough for it to like sink in, just using one example. So for 17, we have this point 5, -2, and we're just going to go ahead and graph that. And it doesn't have to be perfect. So 5, -2 means right 5, down 2. So I'm going to say it's about right there. It just doesn't have to look beautiful. And then so the angle is going to go through that point. And so we can label theta different ways. We can label it like a positive angle, which would be that, which is what I'm going to do. If you wanted to, the other theta could be a negative angle. That would be this one right here. That could be theta. Whatever, it doesn't matter. We're not really using it that much. And they would both have the same sine, cosine, and tangent. Okay, so what we need to do first is find r. So x squared plus y squared is r squared. I'm going to actually kind of like flip that around and say that r squared is x squared, which in this case is 5, plus y squared, which in this case is 2. So x is 5, y is -2, I should say, sorry. And that just comes from the ordered pair, the x coordinate and the y coordinate. Now, whenever you're finding these r's and the x or the y is negative, if you're going to type it in the calculator, be really careful that you put the negative in parentheses. So let me show you how to type it in. I think you probably know this though. All right, that's what r squared should be. And then r is just going to be the square root of that. And 29 is not, the square root of 29 is not going to simplify. It's a prime number, actually. 29 is. So we'll just leave it like that. All right. So r is the square root of 29. X is 5. Y is negative 2. So I'm going to take those three values and I'm going to plug them into these trig ratios. So when I go to find the sine of theta, I'm going to take the y, which is negative 2, and I'm going to put it over r, which is the square root of 29. Now, sometimes you're done. Like, you just do that, and that's all you have to do, and there's nothing else. Are we done on this one? No, because that square root of 29 is kind of a little bit of a pain because it's in the denominator, so we can fix it. It's not too terrible. We'll just multiply by the top and bottom by the square root of 29, and that's the sine of theta. So you can find the sine, cosine, and tangent of an angle that doesn't even make a triangle. It's just a point. Okay, when I go to find the cosine of theta, I'm going to use this rule right here. So it tells us to take the x and divide it by the r. All right, so x is 5. R is the square root of 29. So we are going to have that extra step on this one. All right, so that is the cosine of theta. All right, and then when I want to find the tangent of theta, I'm going to use this rule here. So I'm going to take the y and divide it by the x. So it's going to be negative 2 over 5. That's it. All right, now when I do the reciprocals, we're going to be smart, and we aren't going to flip over the final answer on the sine and the cosine, because that's going to move the radical to the bottom. We're going to flip over this first one, the first one we found. And that negative, it can go on the top, it can go on the bottom, it can go in the front. I usually will just go ahead and put it in the front. So negative square root of 29 over 2. All right, and then when I do secant, I'm going to take this, the green cosine, the original one, and move and flip it. And then cotangent, we just flip tangent, no big deal. Okay. All right, so yesterday on your homework page, I told you to mark out all those reference angles. So still, we're still not doing that. And we are going to do 19 through 21, but we're going to change 19 and we're going to change 20 and 21. Just so they just work out a little cleaner. So 20, we're going to change to the point 2, 3. And 21, we're going to change to 3, negative 4. And then, like I said, I have some more examples to do. So let me give you the other sheet. All right, and then this additional sheet is nothing new. It's the same stuff we just said. I just wanted you to have more examples and more to practice. So same thing, we have theta in standard form, x, y is a point on theta, and if I want to find r, we're going to do x squared plus y squared is r squared. And then I can just use x, y, and r to find all my trig ratios. So again, sine is y over r, cosine is x over r, and tangent is y over x. And then we can just do the reciprocals of each of those for the cosecant, secant, and cotangent. Okay, so the directions are the same. I just made them identical to what we just did. We're going to do 18 and 20 together, and then 19 and 21 will be part of your homework. All right, so 18, we are going to graph the point -8, -15. We're not going to be super worried about making it accurate. We're just going to kind of in our head go 8 left, down 15. We'll say it's right there. Okay. And because the point is -8, -15, x is -8, y is -15, and then we're going to use the formula to figure out r. All right, so I know that r squared is equal to -8 squared plus -15 squared. All right, so when it's a kind of large number like that, you might not know what the square root is, so we can just check it to make sure it's not a perfect square, but it actually is. So the square root of 289 is just 17. Now, when it works out like that, it's actually kind of awesome because we're not going to have to do like any extra steps. We're just going to do the X, Y, and R rules and we'll be done. Okay. So when we go to find the sign, we're going to do the Y, which is -15, over R, which is 17, and that's it. Cosine -8, so the X over the R. And then tangent, we have -15 over -8. Now, what is a negative divided by a negative? A positive, good. So we would want to write that as positive 15/8. So that's really the only extra step we have to do on this one. All right, and then we're just going to flip all these over, and that's it. So this one is great. All right, now we are going to skip down and do number 20. So this point, we're going to go over none, but then go down 3. So that's our angle, where x is 0, y is -3. And then we can find r using the formula. All right, so r is 3. Okay, then we're going to use our x, y, and r rules to find sine, cosine, and tangent. And this one turns out kind of weird, but we can figure it out. So for sine, we're going to do y over r. So what is negative 3 divided by 3?
1.
Close, super close.
Oh.
Negative 1, yeah. All right, and then for cosine, we're going to do x divided by r. All right, so it's 0 divided by 3. 0. And then for tangent, we're going to do y divided by x. So what's negative 3 divided by 0? Nope. Type it in the calculator. What does it say when you type it? It's an error. You cannot divide by 0. So anytime 0 is in the denominator, you're going to say it's undefined. You don't have to say error. You can just say it's undefined. Okay. Now let's do the reciprocals of each of these. So we can flip over negative 1 over 1, or we can flip over negative 3 over 3. I don't know which way is better. We'll go back to the original. So what's 3 divided by negative 3? It's still negative 1, yeah. Negative 1 is its own reciprocal. Okay, so let's flip over 0, or flip over 0 divided by 3. That's going to be undefined. So the reciprocal of 0 is undefined. What do you think the reciprocal of undefined is? It's going to be 0. So if I take that original one and flip it over, it's going to be 0 divided by negative 3, which is 0. All right, so that one turns out kind of weird. All right, do you guys have questions on this X, Y, and R rules? Okay. No. Okay, so what I want you guys to do on this additional sheet, 19 and 21, so make sure you put your name on it because you are going to turn it in. So on the additional sheet, finish 19 and 21, and then on the homework from yesterday, Unit 12, Homework 3, do that 19 through 21. And make sure you've changed 20 and 21, please.